if we have quantitative data, we can create a frequency distribution or a relative frequency distribution or both. How we do that depends on, are the data that we are dealing with discrete or continuous? If the data that we have is discrete, then what we can do is basically the same thing that we did with like the blood type problem. In other words, if we have discrete data, and I should say also with that, if we have like a relatively small number of possible values that can be recorded, then we could just make each value a category and count how many times we get, say, a 2, and how many times we get a 3, and how many times we get a 4, and so on, just like we did with the A, the AB, the B, and the O. But if we have a large number of possible values, then that's probably not going to work real well for us. Instead, we're going to need to group values into intervals, and we'll look at a range of values for each category. If we have continuous data, we don't have any choice. We have to use ranges of values or intervals of values as our categories. Now, the categories aren't really called categories whenever we have quantitative data. The categories are called classes. So the categories into which quantitative data are organized are called classes. So we're going to organize our data into classes. Again, those are just the categories. And that'll either be a single value if we have discrete data, and again, a relatively small number of discrete data values, or it'll be a range of values if we have continuous data or a large number of possible discrete values. So if the data are discrete and there are relatively few different values of the variable, the classes will be the observed values, just like it was with qualitative data. If the data are continuous, or if the data are discrete, but there are many different values of the variables, then the classes are created using intervals of number. So the first example that we're going to look at is like bullet A. We have discrete data and we have a relatively small number of possible values. So I'm going to do that relatively quickly here, and then we're going to get to what we'll do most of the time, which is we'll have to look at intervals of values for our classes. So organizing discrete data, example. Now this comes just straight from your book. The manager of a Wendy's fast food restaurant wants to know the typical number of customers who arrive during the lunch hour. The data in Table 8 represent the number of customers who arrive at Wendy's for 40 randomly selected 15-minute intervals of time during lunch. For example, during one 15-minute interval, 7 customers arrived. So that's what this data value is representing. So again, a random 15 minutes during lunchtime, how many customers walk in the door or order, okay? And so 7 customers ordered once, and then 5 customers ordered a different time, and 2 customers ordered a different time, and so on. We're supposed to construct a frequency and a relative frequency distribution of the data. So this is discrete data because we're talking about number of customers. And how would you determine the number of customers? You count them. So it has to be a whole number. It could be 0 or 1 or 2 or 3 or 4 or 1,000, but it couldn't be like 2.7 customers, right? It's got to be a whole number, so it's countable. Now, also, if you look at the data here, our data values range from 1 right here to 11 right here. So we only have a relatively few number of possibilities from 1 to 11. So because of that, I can just treat each of those values from 1 to 11 as my class. So these are going to represent my classes. It's the number of customers. So all I'm going to have to do in order to find the frequency is just like we did with qualitative data. I'm just going to go through and count. How many times did I have 1 customer? How many times did I have 2 customers? How many times did I have 3 customers? And so on. And then I can change those frequencies into relative frequencies. So quickly here, I'm just going to go through my data and count. So there's once that we had one customer, and that's it. We had one customer one time. Two customers, well, that happened once, twice, three times, 4, 5, 6, and that's it, 6. So there were 6 different time periods where we had 2 customers only. 3 customers, there's once, and that's it. So our frequency is 1. 4 customers, 1, 2, 3, 4. So that happened 4 times. We had 4 customers 4 different times. 5 customers, 1, 2, 3, 4, 5, 6, 7. 6 customers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 different times we had 6 customers. 7, we have 1, 2, 3, 4, 5. So 5 different times we had 7 customers. 8, there's once, twice, and that's all I see. 9 customers, 1, 2, so it looks like 2 again. 10 customers, that never happened. There was never a time in our data where we had 10 customers, so the frequency is 0. And last but not least, 11 customers, that only happens that once. So these are our frequencies. And just like we did with qualitative data, those should add up to the number of data values. We had 40 data values. So if I add up 1 plus 6 plus 1 plus 4 plus 7 plus 11 plus 5 plus 2 plus 2 plus 0 plus 1, that adds up to 40. If it doesn't, then I know I've miscounted. I've goofed somewhere. So that does equal 40. Now, again, that doesn't guarantee that I didn't goof up. Like if I had counted and made this 5 and this 2, for example, it would still add up to 40, okay? And it would technically be wrong there. So it doesn't guarantee I'm right, but if it doesn't add to 40, I know I'm wrong. Change those to relative frequencies. So just like we did with qualitative data, there's 40 values altogether. So if I take 1 divided by 40, that is 0.025. So my relative frequency is 0.025. 6 divided by 40, that is 0.15. Now I could write that as 0.15, but personally that kind of bugs me because this has 3 digits and this only has 2. So my personal preference is to go ahead and put a 0 back there so that it is 0.150. So they're all the same number of places. 1 divided by 40 would again be 0.025. 4 divided by 40 is going to be 0.1. So 0.1. And again, I like to put 2 zeros there just so that they all match with 3 digits. 7 divided by 40, that's going to be 0.175. 11 divided by 40, 0.275. 5 divided by 40 is 0.125. 2 divided by 40, that's 0.05. But again, I'm going to put a 0 behind it. I'd get 0.05 again. 0 divided by 40 is going to be 0. And so again, I like to keep the number of digits consistent. And last but not least, 1 divided by 40 is going to be 0.025 again. And if we add those up, that should add up to 1. If it doesn't, then I've done something wrong. Or, like I was telling you with qualitative data, if you have to round these, then that could possibly make it not add up to 1 exactly, depending on how the rounding goes. Not really anything different from what we've already done in section 2.1. But this kind of situation is going to be pretty rare for us. Usually, you're not going to have just a few discrete values that can occur. So this can happen, but it's going to be fairly rare for this to happen to us. Now, when we create graphs of quantitative data, we don't create bar graphs. Instead, we create what are called histograms. Now, a histogram looks like a bar graph, but the difference is that we have a meaningful scale on the horizontal axis that we don't have when we have qualitative data. So the qualitative data doesn't really have a scale on the horizontal axis, but quantitative data does. So this is representing 1 customer, 2 customers, 3 customers, up to 11 customers. Now the vertical axis is going to represent either the frequency or the relative frequency, just like we did with qualitative data. But again, the difference is the horizontal scale. So for that reason, because there's meaning in the horizontal scale that we didn't have in the qualitative data, we give the graph a different name. It's no longer just a bar graph, it's called a histogram. So a histogram is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency of the class. The width of each rectangle is the same, and the rectangles touch each other. So I'm going to use this definition, and I'm going to construct a frequency histogram for the Wendy's data. So here's how I would do a frequency histogram for the Wendy's data. So 1 customer, we had that occur 1 time. If I pull back in my data, that occurred 1 time. So my frequency was 1. So I'm going to create a bar that has a height of 1. Now again, to do that, what I'm going to do is I'm going to center that bar. And actually, I got my bar just a little bit too tall. I'm going to center that bar above the value 1. Now for 2, that occurred 6 times. So I'm going to start where I stopped this bar, and I'm going to go over, I'm going to go up to 6, I should say, and over and back down. Now notice the width of my bar here. I'm going really from about halfway between 0 and 1 to halfway between 1 and 2. And I'm going to continue that. I'm going to go halfway from 2 to 3, and so on and so on and so on. So 3 occurred once. 4 occurred 4 times. 5 occurred 7 times. 6 occurred 11 times. 7 occurred 5 times. 8 occurred twice. 9 also occurred twice. 10 never occurred at all. 11 occurred at 1 time, I should say. So this would be my histogram. So again, what's the difference between a bar graph and a histogram? A histogram is when we have quantitative data, so there's meaning in a horizontal scale here that we didn't have with qualitative data. So there's meaning to the width of these rectangles that we didn't have with qualitative data. In this case, each rectangle represents a width of 1. It's a change of 1 customer. Now I could do the exact same thing for the Wendy's data if I wanted to create a relative frequency distribution. But I want to show you a different way that this kind of data is being graphed as well. I wouldn't technically call it a histogram, but because this is discrete data, what is becoming a more common practice is instead of using rectangles, we just use vertical lines. So I might have used vertical lines instead of rectangles for this data. So here's what I mean by that. So my relative frequency for 1 was 0.025. Now 0.025 would be about right here vertically. And so if I just put a point there and then draw a vertical line down to 1, that would indicate the relative frequency of 1 is 0.25. Now the relative frequency for 2 was 0.150 or 0.15. So that's up to here. So again, I could do the same kind of thing. Just put a dot and draw a vertical line. And the relative frequency for 3 was 0.025. So a dot and vertical line. And the relative frequency for 4 was 0.1. So there and my vertical line. For 5, the relative frequency was 0.175. So here and draw my vertical line. 6, the relative frequency was 0.275. 7, my relative frequency was 0.125. 8 was 0.05. 9's also 0.05. 10 was 0, so I really don't have a line at all. And 11 was 0.025 again. Now again, to be clear, I could have used rectangles here, just like I did here, and it would still be a relative frequency histogram. But this technique is becoming more and more common. So you would see this kind of graph instead frequently because this vertical line indicates that we have discrete data. Like that line's literally representing 1. That line's literally representing 2 and 3 and so on. Whereas when we use rectangles, as you're going to see when we talk about continuous data, this could represent a range of values. So this could be representing like from 0.5 to 1.5 and from 1.5 to 2.5 and so on. So again, it's not clear from this graph that we necessarily have discrete data, whereas here it's very clear this is discrete data. So again, these are called histograms.